So we can use mole ratios as conversion factors because as you can see here, we have them as conversion factors. And so we use a mole to mole conversion factor. I usually will just call this a mole ratio, and it gets us from moles of one thing to moles of a different thing. So see if we can pause the video and look through this one. If we start with 3.5 moles of C2H6, can you find the mole ratios and figure out how to get some moles of CO? So we're looking from this one to this one. So pause the video and see if you can work that out. So as you see here, we have mole conversions, the 2 in front of C2H6 and the 4 in front of CO. And we can write that in either way, right? We can choose, if we have an equality, the equality would look like this. It would be 2 mole of C2H6 equals 4 mole of CO. And if we have an equality, we can write it in either fraction way. If we start with the moles of C2H6, we need the C2H6 moles to go on the bottom. And so make sure that you're also writing the substance, not just the unit here, because the units are all the same. We cancel out our moles of C2H6 and we get moles of CO. And so we can do this math to get an answer. It's just another conversion factor, so don't let it freak you out too much. So let's say if we wanted to go to grams of products, and now we can think about adding these things on. And so we'll use molar masses if we're interested in finding grams or converting from grams. We use mole to mole conversions if we're interested in changing substances. So try this one. If we start with 9 moles of O2, how many grams of O3 would that be? So pause and try it. So first we have a mole ratio, right? So the mole ratio is going to be 3O2 and 2O3, and we can use it in either way. If we're trying to go to moles of O3, we will use this version, cancel out the moles of O2. Now I wouldn't stop and solve here, I'd actually keep going. So if you kept going, that's great. If you did stop and do a piecemeal, you can, but I recommend that you try to keep going because we don't really want to stop at moles of O2. We want to go all the way to grams. So we can think about how we're going to use the molar mass in the next step. So for molar mass, 3 O's is going to be 48 gram per mole. And so we can write either fraction like this. And then we would say, well, if we have moles of O3, we'd want to use the moles in the bottom and the grams on the top. So that would be your answer. I want to show you what I would do for this. I would actually do it all at once. So I would do 9 moles O2 for every 2 mole O2. Actually, that's a 3, isn't it? 3 mole O2, I get 2 mole O3. And then I would say 1 mole O3, 48 grams O3. And then I would still get 288 or 290 grams of O3 if we're rounding for sig figs. So you get the same thing. I think it's a lot faster to do it all in one long step. So you can just kind of cancel out to see if you're checking your work there. That's not a comma in the sense that that's a comma. It's either that number or that number. So of course, if you have questions during the video, you can always take a picture of the screen and ask me, what were you doing there? Why did you start with that? Why would we put that number there? But we can go back through the steps if you need to try to figure that out. All right, let's try this one. Converting grams of reactant to grams of products. We're going to go all the way from grams to grams. So we're going to need to think about using the molar masses and the mole ratios. So because they give me grams, we need to know the molar mass of ethylene. So that's given to us here. If we need, so they give us grams, so we have to have the molar mass of that thing. They ask us for grams of ethanol, so we need the molar mass of the ethanol as well. And then there's one thing that's kind of hidden that we need. We also need a mole ratio because we're changing substances. Let me put this in green. Right, we're starting with ethanol and we're going to ethylene. We're changing substances, so we also need a mole ratio. And we can look to the chemical reaction to find that out. In 1 mole of C2H4, there's 1 mole of C2H6O. And I know that you're thinking if it's a 1-to-1 ratio, it's not going to matter for your math. It does matter for your units to cancel. So you're going to include that. So we've got 3 conversions here: molar mass, mole ratio, molar mass. See if you can put that together. So here's the plan. You're going to use molar mass, then you're going to use mole ratio, then you're going to use molar mass. And to put that all together, this is what it would look like. And so notice that we're canceling moles of C2H4 with moles of C2H4 and moles of C2H6O with moles of C2H6O. You can't cancel moles just with moles. You gotta be specific. So if you have questions, please let me know, but we will go over this a lot in class.